Hello again, and welcome to the Open Systems Firmware panel. We're going to talk about the schedule for our transition to Open Systems Firmware on OCP systems. I've got some really terrific people here who are going to address some of the questions that we'll lay out in a minute. We have Elaine Palmer from IBM, Jeff Krantz from HPE, Dong Wei from ARM, and Isaac Orm from Intel. And we're just going to have a discussion here about how we move forward. All right, so I'm going to quick revisit the subject of what open system firmware is and the schedule, and then we'll turn to our panel. So again, the goal of open system firmware is to allow owners of systems to configure, construct, install, and use their own firmware on their systems, and further to provide the firmware they construct to other owners without restriction. I actually use the word construct, not build, because I'm trying to get away from a little misunderstanding here that all the firmware has to be open source. We do accept that some firmware on some systems might be binary. It's just that they need to be licensed in a way that I can redistribute them, or the owners can. The Open System Firmware Committee, or OSF Committee, has defined and published what constitutes compliance with these goals. That's an open document available. Just get in touch with us and we can give you the link. And we also defined a schedule. Last August, the OCP approved the transition schedule from where we are today to the open system firmware world. But for coronavirus, we would have been announcing this about 2 months ago at the summit. But for coronavirus, in the meeting in the fall, the OCP summit in Prague, which is no longer going to happen, we would be trying to demonstrate systems. So we'll see how this all goes. And if we get to our March 2021 date, I've been told there's been a lot of disruption going on right now. So we'll just have to see how things work out for the schedule. The March 2021 date was the result of a lot of discussion among ODMs and chipset vendors and owners. So here are the questions. The way we're going to try and do this is ask the question, and then each panelist gets 2.5 minutes, and I'll try and give you a warning when you're about to hit your time. And then we'll move on in turn, and we're going to take them in order: Elaine, Jeff, Dongwei, and Isaac. So the questions are basically, are you there today? Will you be there in September with maybe early adopter systems? Do you expect to be there next March when we are hoping to make it mandatory? And what challenges are you facing or have you faced in meeting these goals? So first question, and I'll hand off to Elaine with the next slide, are do your company's products meet the OSF requirements today? And if so, how, and can I buy them today? So Elaine?
Hi, thanks, Ron. The quick answer is yes, they meet them today. Our open power, not based on the Power 9 processor systems do. Not all of our power systems do, but the ones that are labeled branded open power do. And this diagram shows what we have strived to do, which is to make the entire stack all the way, starting from the firmware, all the way up through the operating system open and open source. We have done that. Everything's available on GitHub. And this effort started around 2013. So it's bit by bit coming along and opening up more and more. And now it is entirely, including, as of last fall, the instruction set, OpenCAPI, and the open memory interface too.
All right, well, thank you.
Yep.
I am going to record the time, so Ellen, if you need more time later, you'll have it.
Okay.
Okay, Jeff?
Yeah, this will be my shortest answer of the four. Today, HP Enterprise does not have OSF requirements met within our server portfolio. It's definitely something we're looking at, and I'll address that in item number 2 when we get there. And so, yeah, that's it. Okay.
Dongwei?
Yes, so our answer is yes, absolutely. So everything we do in ARM is, in terms of firmware, is to do it in open source, and we work with existing projects like Trusted Firmware, Tiano Core, EDK2, U-boot, whatever have you, to make sure that ARM IP are well supported in the mainline code base for the open source. However, ARM doesn't really ship processors or servers directly, so we work with our partners to provide, the associate firmware for their specific hardware, and most of them also provide open source firmware as well. But there are some exceptions. So, for the parties interested, you would need to check with the vendors who are shipping the server systems and confirm on a specific project. I have some examples here. So Ampere is a silicon provider. They support the open source firmware program. Ampere is actively working and providing EDK2 and OpenBMC support on Ampere platforms. Also, Ampere has been working with system owners to build and install their own firmware in order to provide more control over and innovations in the system. Marvell is another silicon provider, and it has been supportive of and very actively involved in various collaboration in the different forums since the beginning of the ARM-based servers, including delivering the server-ready compliant processors and firmware for ThunderX ARM-based server processors. Marvell also collaborates with Microsoft quite a bit in the first dual socket ARM-based OCP. Project Olympus design that they have. And then Marvell also supports the OSF, the Open System Firmware here, this project initiative in the OCP with active contributions to the project from their firmware architect. Marvell also collaborates with system partners building ThunderX-based platforms and will enable partners in delivering OSF compliant systems as people need.
Okay.
The processor vendors, there's a processor vendor in China called Phytium. They are also willing to provide open source system firmware, in terms of U-boot or EDK2. So
Okay.
I think we have a very good, strong support in our community for the open source system firmware.
Okay, thanks. And Isaac?
Hi. Today, our existing products are based on a mix of proprietary and open source firmware ingredients. So some of those proprietary ingredients are required and are not available. And some of the open answers are incomplete as a result. So generally speaking, for all practical purposes, our current generations of products do not support OSF today. We have been working towards that by enabling relicensing many of the binary pieces that are required, and we're working to produce a new solution, which we've called the EDK2 minimum platform architecture, that we can fully open source for our reference platforms. So over the last 18 months, we've been putting examples of the various pieces in place, and we're looking to go forward and get those into the next generations of products.
Well, thank you. So the next question, how are we doing for September? In other words, and it'll be the same order answers. How do you feel about getting evaluation systems, OSF compliant systems to early adopters in September? And I guess this will be the easiest one for Elaine to answer. So we'll start with Elaine anyway.
Okay, and what you've got there showing are pictures of two of our open systems, which have already meet the requirements. So you have from the very first electron applied, you have open source available on GitHub with very generous licensing, all the way up through and into Linux. So these are two systems, for example, that are available today. They're based on our Power 9 processors, the latest ones. So the answer is yes, here they are.
I like the exploded diagram. Okay. And then Jeff?
Thanks, Ron. Hey, everybody. So traditionally, HPE has been very proprietary. You know, we would participate in certain open standards such as redfish development, but there's many other areas where we would go it alone. We would design things our own way, and would not necessarily participate or even adopt things that were being done in the OCP marketplace, for example. We're absolutely trying to change that. It's clear to us that many of our top customers, both service providers and other top customers, are interested in open system firmware on our products. We have already been working on this for 9 months, and as you know, Ron, we recently demoed both a ProLiant running OpenBMC firmware and a ProLiant running Linux boot firmware at the Open Compute Summit that was held in last fall in Europe. We were poised to do the same thing again in the spring, of course, before that was canceled. We also showed off both those at the FOSDEM conference in Brussels a few months ago. So we've already got it working, and really the issue for us is collaborating with customers on how to get this to market. We have enabled a few select customers with these demos, and we're working with them hand in hand to see what their experience is like and how we fine-tune what our offerings would be. And we're making very good progress. So I would, so we have beat your September date. We've already got products in hand, and we are willing to expand that to additional customers where it's merited.
That's neat. Thank you, Dongwei.
Yeah, so for ARM, we have been working on this, and so OSF compliant platforms from our end are already available in the form of an emulation platform, as well as our N1 SDP software development platform. So all of the firmware for those platforms is already open source. ARM also provides the specifications and reference implementations that enable our partners to provide OSF compliant systems. And as I was talking about just for the first question, right, our partners like Ampere and Marvell and Phytian are very willing to work with the partners, and they already have the solutions in terms of open source system firmware compliance.
Yeah, and I am working with Ampere's, the N1 STP, so I know what you mean. Thanks. Isaac? Yeah.
Hi. Yeah, so I want to frame my answers before I get into too much detail in that Intel does enable a wide variety of products. So I'm not talking about any system products or channel products directly from Intel. I'm more talking in the context of our silicon product enabling and our ecosystem partner readiness, not about some direct Intel branded or channel oriented product that we may produce. So with that said, we are working and expect to be working with our partners in the September timeframe to produce the products that meet that Global Summit March 2021 target date. Our contributions are not complete solutions, but elements of the bill of materials. And so our primary contributions will be some open tools, open source tools, tianocore.org, EDK2 contributions, Intel firmware support package binary blobs for our silicon, the Intel PCH Ignition firmware binary blobs, as well as microcode updates, and an open source EDK2 minimum platform architecture based bootloader. So we'll put out the pieces necessary for our reference platform and then work with the ecosystem to produce solutions based on either EDK2 or other bootloaders if people so choose. So we're not particularly bootloader, we're fairly bootloader agnostic, but our reference bootloader will be based on EDK2. And we think that with these ingredients, our customers and partners will be able to hit the March deadlines, or March targets, I should say.
That's great to hear. Thank you. Okay. By the way, you're all doing a terrific job of keeping us on time. I really appreciate it, and I think the audience will too. So to some extent, this question seems to have been partly at least answered because you're all kind of hitting the mark in September, which is, I think, quite incredibly good. But anyway, let's go ahead with it. Even though we almost know the answer, how do you feel about the March 2021 deadline, Elaine?
Yeah, so we have a new CEO as of April 6th, Arvind Krishna. And Arvind has been totally passionate about open standards, open source. We certainly have our customers who are actually delighted to have the flexibility of the open source. We found that some of them just want to have no secrets. They just want to be able to see the code. Some of them want the ability to build and sign their firmware themselves, but they don't want to modify it. They just want to be in control of it. Some of them want to actually modify the code. And then there are some that we don't know what they're doing with it, but they don't tell us. So as far as how do we plan to do this going forward, we're totally committed. The more we can get open, the better. We find our customers prefer the flexibility that it offers.
Okay. And next, Jeff.
Yeah, so I don't think it's quite as easy as you made it out to be, Ron. So yes, we are achieving proof of concepts right now, and we're testing it. And I also framed up a little bit that in the past how HP's been, right? A little bit closed off, not participating as much as we should have. We're absolutely trying to change that, and so you're going to see that from us all over the place. Meaning, the way we source options, the way we open source things that we're doing, the way we embrace open standards that the OCP community is doing, as well as others. And so all that feeds into, this open source firmware situation also. We are looking to do what we can to align with our next generation product launches, which would align with the next generation of CPU launches next year. That may or may not make March. I think for us, the biggest challenge is getting past the enablement stage where we're working with key partners to see how this is going to work to actually taking it to production. That's a little bit different, right? And so there's some challenges there, and we're working through those. I don't think anything's stopping us from being ready. As Isaac just mentioned, Intel's contributing as much as they need to do, and so I think it's really a matter of figuring out exactly what we want to do and how we're going to do it. And I know that's part of that is what question 4 is about. But we really want to get there. We're also trying to look at this problem across our product lines, right? We've got ProLiant servers, we've got Apollo high performance computing servers, we've got Apollo storage servers. And so we need to think through, how broad or how wide we can go. But if anything, I think we'll start small. We'll try to get this to production, maybe not publicly. It may be a private offering for early adopter critical customers who are really interested in this. And then we'll see at what point we can make this a wide offering that's public across a bunch of different products. I would add in that I'm definitely seeing, as I talk to large service providers and big customers, that the initial trend seems to be wanting to embrace a open BMC versus BIOS at this point. I think it feeds back to just a few different things, but it seems like that's what they're ready for. And so that's what we're prioritizing. But really, ultimately, we want to just make the platform able to support open source firmware in general so that we're not constraining anybody.
Okay. Yeah, Jeff, I don't mean to sort of understate the amount of work that this involves and that HPE is doing. It's a pretty big effort. Well, a huge effort from my point of view. Okay, Dongwei?
Yeah, so as I said, I think from ARM's point of view, we are already doing the open source. Most of our SoC vendors are already providing firmware in the source format as well. So, of course, as I have said before, ARM doesn't produce the actual products. So the interested parties would need to check with the SoC vendors to confirm, they're able to get the OSF compliant firmware when they procure the system. But as I mentioned before, our partners are generally already on board. So, I've provided a few examples. So, the interested parties can check with them and get the right, systems with the open source firmware.
Thanks. So, and Isaac.
All right. Well, yeah, as you pointed out, we kind of answered the question before, so I think I'll elaborate a little bit on what we expect in terms of a relatively small number of OSF, open system firmware SKUs. We don't think we'll see broad adoption across all SKUs. Essentially, from our perspective, OSF requires a different SKU than many of our traditional products due to security features and what I see as essentially conflicting requirements between firmware security and firmware openness. So there's some challenges on that I think will make the initial number of SKUs a little bit more limited, but I think that's fine, and I think that's a reasonable way to get there. The other challenge I think we'll see in March start to rear its head is how much of the system firmware is open. We don't expect to see the full open solution, full open system firmware or BIOS or bootloader solution on our platforms. We'll see the mix of proprietary features on top of the open minimal features. So we do believe that there will be open solutions, but they won't be fully featured as compared to the more proprietary solutions. So that seems like a reasonable first step, and I think we'll meet that in March, but that's basically what I'm guessing is we're likely to see next year.
All right, so this is really good stuff. Now, you all have been terrific about really speaking well and keeping it on time. You've each got 5 minutes to, if you have anything else you want to say about the challenges and the issues you face and have faced, and where you see this going in terms of SKUs and all that kind of thing, and what changes in the chips and boards and systems and manufacturing and distribution to kind of make this work. And so again, I'll start with Dongwei.
Hi. Yeah. So actually, it's interesting. Providing the OSF compliant firmware in itself isn't a big problem for us, for ARM. Rather, our challenge is to ensure, the consistencies of functionalities across the ARM ecosystem. Because we have very many silicon providers doing innovations for the processors. So we have the challenge that the OS vendors need to have the ability to reliably deploy onto many of our ARM platforms. So we have tackled this problem by providing specifications and creating, this server-ready certification program that the OS and software vendors can rely upon. We also have set up the trustedfirmware.org open source project to make sure, from the reset vector all the way up to the OS, operating system kernel, we have a way to enable the open source. And we actually also actively contribute to Tiano Core EDK2. We are also working very closely with Google to ensure that the interfaces required for the Linux boot enablement as well. And so all these are covered by the ARM platform standards efforts. We believe the ARM ecosystem is very well set up to deliver the OSF compliant system. So we are very happy to be able to support this effort.
That's great. Thank you. And then I guess next we'll go to Elaine.
Hi. So we certainly have had challenges in getting to this completely open system, one of which has been having to do with secure boot, because secure boot, of course, requires initial keys to start off with, and having there's a sort of a conflict between total immutability, this is the key put in by the factory at the beginning of time, versus the flexibility of being able to change it. I've given talks at other OCP summits and such about ownership and how it affects your supply chain. How do you initialize things? There are various multiple ways in which you can put your initial keys in and then send the product on its way through the supply chain. It certainly depends on what level you're doing it, whether it's at a chip level, a board level, system level, who's going to catch it at the other end, who's going to change the keys or leave them as they are. It's not a simple problem to solve, and it's very much tied to your supply chain. We do find that when we can, we prefer to have totally hardware protected keys that we put in as early as we possibly can in the supply chain, and those stay as is unless there are customers that absolutely must change those, and we allow them to be able to do that. So that was one of our early design points on how exactly to do that. It's not totally easy. It's not like you just go and flip a switch and you can go change the owner on these systems, but it is feasible to do. I wanted to mention something too that Isaac talked about with limited SKUs. We indeed have the same setup, I guess, in that some of our systems are not totally open, and there are many reasons for that, some of which the code has come from other suppliers who have restrictive licenses. Some of the other reasons are that for warranty support, if customers can go willy-nilly changing their firmware around, then what do we do when they've toasted themselves and they're still under warranty? So there are multiple issues involved. So in our case, we too have limited SKUs for the totally open systems. They're based on the same foundations, but the code and the firmware would be different, and a few of the pieces of hardware are different, but generally they are mostly the same. And something that Dong Wei mentioned, as far as the systems and the different components in the different parts of the system, we are emphasizing the whole ecosystem of boards and chips and systems all having the same secure boot functionality and open firmware in them. So when it comes to the complete system, ideally each adapter, each board, each chip, every component that comes from a supplier that has its own firmware would be able to securely boot itself and attest to what it's running and then join the system. And that's one of the projects going on in OCP in the security project, which is how to define that ecosystem and all of the protocols between the different parts of the system.
That's really good. Thank you very much. That's really important points. Okay, Jeff?
Thanks, Ron. I was actually supposed to give a whole session on this at the OCP Summit, so I will try to pare it down to 5 minutes for you. And I will also try to not parallel too many topics that Elaine brought up, because there are some similarities there. Absolutely, as an OEM, HP has some challenges here. Our number one thing we want to make sure as we go try to enable this for our customers is to maintain security for all the other customers that don't desire open source firmware. And even for the ones that desire open source firmware, how do we keep things secure across customers? If something nefarious was to happen purposefully or accidentally. We brand our Gen 10 servers as the world's most secure servers. We have our ILO chip down with Silicon Root of Trust. And as great as that is, it kind of poses some challenges here because we're so tightly secure. How do we go make this happen? So initially, our first thought, our first plan was we would need unique versions of motherboards for anything that was going to run open source firmware with unique chips, with unique fuses. And, that's a supply chain challenge. That's a cost challenge. It's kind of a headache, especially since we we're projecting here next year, if we were to roll this out, that it'll be, you know, a minority of our customers that want this. It'll be very few, very sophisticated customers who have the engineering expertise and prowess to kind of take this on and directly partner with us for success here. We see some challenges with just enabling anybody at this point, just because if there's issues, you know, how do you handle them? So, you know, security is our first concern, and how do we navigate that? And so we've got some other ideas on maybe some ways we could do it without having to have completely unique hardware. Because if you head down that path of having a unique supply chain of materials, it's really going to constrain what products you can ultimately support this on. And in a perfect world, we'd be able to support this on anything that we do by landing the right firmware on there, given our, you know, I would say commonality across our core server architectures. You know, another challenge is warranty considerations or service considerations, right? If a customer puts open source firmware on a platform and has issues, you know, who owns resolving them, right? And when I talk to customers about that exact issue, most of them are say, you know what, I'm never going to touch anything that would ever break anything. You know, I'm not going to turn off thermal control and your processors overheat or something else. And I know everybody has the best intentions, right? But to avoid finger pointing, you know, how do we sort through contractually how service will be provided? And even if it's not a warranty issue itself, what if a server gets resold later, repurposed to a different customer or to the open market when its end of life is passed at a specific customer? You know, how do you handle those situations? So we are working to sort through all that. Again, we deal with tens of thousands of customers a year, and we think it's a very limited number that are initially ready to go tackle this at any kind of scale. And that's what we're probably looking for as far as partnering on this, is some of the more sophisticated customers with the larger engineering team in-house who want to roll this out and can provide the level of support that it's going to take to be successful here. As far as unique SKUs or unique part numbers, I think, as I mentioned, we would like to have unique part numbers just for like ordering purposes, but the hardware itself to be the same as what we would have on our ProLiant or Apollo platforms. It's really just a matter of how you implement the security on those motherboards and how you control, you know, firmware signing and such. We definitely don't want any kind of scenario where a customer is able to sign their own firmware on these boxes and then be able to take that signed payload and successfully run it on a non-open source box or a different customer's open source box. We really want to try to lock it all down so that there's no, I don't know, cross-contamination of code bases, and that, you know, purposefully or accidentally nothing can happen that shouldn't be happening. As I mentioned earlier, we do see the open source demand to be fairly limited in 2021, but we absolutely want to get there as we launch our next generation of products. We're just sorting through all the details, and sometimes the devil's in the details, right? And so we are working through all that. It's less of a technical readiness challenge of the code base, and it's more about just the challenges that we have as an OEM in getting this enabled and making sure our customers are ultimately happy with what we source to them. And so, as I mentioned earlier, right now we are doing some pilots with different customers, trying to work through that and ultimately be successful and ready when next March.
All right. Well, thank you. You nailed 5 minutes too. And then finally, last but absolutely not least, of course, Isaac.
Well, I feel like I'm in a bit of a hard spot since most of the good challenges have already been elaborated on, thanks. The ecosystem hardware skewing and the security challenges, we definitely hit both of those. I'll share a couple other that I think that are relevant to people looking at this. One is that OSF, Open System Firmware, is starting fairly small with respect to the required features and with respect to the required Open System Firmware source code requirements. But this, so this is generally wise, and it makes the plans more realistic and more people can join us on this, but it's also an incremental effort for most people. So this has been a significant challenge because we're trying to jump on a moving train. So this is a common problem in this industry and ecosystem, but that's the first challenge I bring out there. Second, the security, and third, we've hit some challenges on going through and balancing intellectual property considerations as we relicense our binaries and pieces and open code. And so those are the three broad categories. We as Intel have a fourth challenge that's more specific to silicon vendors, which is the ecosystem enabling. And so now we have, where we used to have one fairly straightforward ecosystem with BIOS vendors, customers, ODMs, and things going, we're now having a second path that impacts everybody in some slightly different way. So we have the proprietary path that's existing and handles much of our business, and we expect it to continue, and this new path of open pieces. And so there are new challenges with respect to schedule, when we can share things openly. So we can't be truly open early on in projects, and some of those kinds of challenges have been really interesting for us as we evolve down this path. So yeah, so that's the biggest one we're dealing with now, is how do we catch the moving train and provide this two set of enabling answers that work well and have consistent quality, and people can understand the trade-offs between open and proprietary solutions and those kinds of challenges.
Well, thank you. So this is the point where I would say, please thank our panel, and we'd get a room full of applause. And I forgot to get the sound effects, but I really appreciate everyone taking the time to show up. And I really thought these were great answers, and I think they're going to prove to be very valuable for all the owners who are looking at open system firmware and how complicated these issues really are. It only seems simple. So really appreciate the time, and we really nailed it in terms of keeping it on schedule. So thanks for that too.
I'm here on the phone for question Q&A. Is anybody else there?
Yeah, I'm here.
Yeah, excellent. We can take questions. The questions would have to be typed in on the Q&A part of the screen, and we can answer them there or here.
Are there any questions?
I think the ones we've gotten so far have been answered online. I don't know if there are any. I don't see any new ones.
Okay, I dialed in because I don't know how to use the tool.
Well, that was the right thing, Ron. It was what we were supposed to do, so you're good.
Oh, okay. I've only seen a question on quantum computing, which I am not remotely qualified to speak to. So
Yeah, that
I guess
it's
that
a,
Ron, you at the end of the call, you need to say something about we're done, something like that.
About what?
Just telling people that we're done for the session, right? But I haven't seen any other questions. Oh, there's a question about what are the trade-offs between open and proprietary.
I'm not seeing that question, but
the
first
7.
one. Why am I seeing no questions?
question number 7. You scroll down.
Yeah, I just see 2 questions on the question. I'm going to reload the tab.
So it's Jack.
What are the trade-offs between open and proprietary?
Ron, you're going to take that one?
Well, I think that I mean, if you go back far enough in the microprocessor world, at some point things were pretty open, and in fact, and this goes back to the 70s and 80s, when a company came out with a microprocessor, they had to demonstrate there was a second source, because the concern always was, well, a company goes out of business, then where are we? So traditionally, up through the 90s, things were really very open, because the people that bought these systems wanted to be sure they had a backup plan. So I kind of grew up in that era where things were always open, and I infinitely prefer things to always be open. And I think, I prefer things to be the way IBM does it. So, I'm biased here, but my point of view is the advantage of the proprietary tends to accrue to the companies selling the proprietary system, but not to the advantage of the end user. And I also am glad I'm not in a hardware business, because it's a brutal business, and I can certainly sympathize with a company that would try and maintain competitive advantage by keeping systems closed. But I've never been able to figure out a way in which that really helps the owners of the system. So that's my take on this anyway.
Yeah, I would add that from a security point of view, it helps to have not just many more eyes, as was earlier mentioned in an earlier talk, but earlier a view from experienced eyes who are experienced in the security world and can help to catch things.
Hey, it's Jeff. Can you guys hear me?
Yeah.
Okay. I had to take a page from Ron's book and dial in. I couldn't get the tool to work. I was trying to answer one of these questions here, but when I go into it and I type in something, I don't see how to post it. I was trying to answer question 8. It gives me publish without answer or a bunch of drop downs.
Yeah, I'm not even seeing that, but that's okay. You can maybe read. Someone can read question 8 out. Would that be possible?
How big would the effort be to make all open firmware initiatives backwards compatible with existing and running SKUs?
Oh boy.
So what I typed in was, this is from Matthew Corteo. I said, look, it depends on the manufacturer, the platform, and the constraints involved. We have this code base running on our Gen 10 products, but that only works best for us if HPE is the one signing the code. There are complexities for us to remaining secure, yet enabling customers to compile their own code. And I think it'll be different for everybody depending on the situation and the platform.
Yeah, I mean,
this is Isaac. This is Isaac
go ahead.
for Intel. I'd say it's a big enough effort that we haven't seriously considered it. So it usually is viewed as a non-starter for us to go backwards. So that's why we have this forward-looking approach, because we can conceive of that much more easily. But yeah, we acknowledge the request and the demand is out there for sure.
Yeah, and from the IBM point of view, even the systems that have been open in the past, our earlier processors, when there are newer features in the newer systems like our P9s, Power 9s, we don't go backwards to retrofit those back into the earlier systems. In fact, in the really, really early systems where we weren't completely open yet, one of those problems was, again, licensing. If we had gotten code for some firmware within a specific device or a driver of some kind, those we did not have the rights to make it open, so we couldn't. But, as we go forward, we keep pushing on our own vendors as well as ourselves to keep things as open as possible.
Yes, it's Ron. I don't think going back is probably really practical. There's a huge amount of work being done, very impressive work in the Corvo community, for example, in the open source Haswell DRAM startup, but we're looking at a 10-year-old platform there, and I look at the amount of effort, and it really is pretty gigantic. So I'm personally a lot more interested in how we move forward and really take. If in my heart of hearts, I'd love to see the community really go after the new platforms rather than the old ones. And again, I can't see the questions. I'm really sorry. So if anyone sees a question that they think we should address, let me know. We've got 8 more minutes.
The other late one was, what are the trade-offs between open and proprietary? Which
yeah, I think
you
we
said,
handled.
Elaine, we answered live. That can be very, that could be a big list. I think, for me, one of the big trade-offs is if you're going to be open, it really increases the engineering resources you need to apply towards that. It gets you in more of a mode where you're doing self-sustaining and, source tree ownership and working with the community. If you're seeing an issue, needing to work with the community instead of a big vendor to resolve it. And that's a huge challenge there. And that's why in my answers, I was thinking the initial adoption would be more from larger companies with more resources available to work this. Now, there's the possibility that if someone wants to run open source firmware, maybe because of an industry that they're in and just by rule, they demand it. And so they'll be looking to ODMs or OEMs or whoever they're buying the equipment from to source their own version of that tree, right? So someone could ask us or IBM or whomever to provide OpenBMC, for example, that we compiled and we curated. And hopefully curated means it's exactly what's off the tree, right? And we sign it. But there's, that's another option here. And then, the onus is back on the manufacturer to kind of stand behind that and source it and maintain it if there's an issue. Those are the struggles we're dealing with, is how to handle that. And then I think you'll also have feature differences between open code stack and a proprietary code stack. Of course you will, right? But that could be a good or bad, pros and cons, depending on which stack you're looking at and which features that you value.
Yeah.
I mean, as you know, everybody, you have a lot more flexibility to do things if you've got an open stack, and if you want to really streamline it and pull things out or do things a different way. Again, if you have the resources, you could go do that. And what we might see is, certain industries and certain companies or governments demanding open source or not open source. It could go either way, right? And then, that's why you have to have a suite of offerings if you want to play across multiple spaces. And, branch predicting what's going to happen a couple years from now is always difficult. We still have 38 people hanging around on the chat. Any other questions?
Well, I think this is a great time for anybody who wants to, since we're all stuck at home, make a coffee.
I thought maybe you were gonna sing us a song or something, Ron.
Oh God, no. No, you couldn't unhear it.
Okay, well, I hope everybody enjoyed the panel discussion. I think we had an expert panel. Everybody did a great job. I appreciated meeting you guys and collaborating with you. And thanks for pulling this together, Ron, and being the host.
Yeah, I guess I am going to take this one moment to announce a new effort around AMD. And AMD's told me I can talk about this now. For people who know what the PSP does on AMD, it basically gets all of DRAM ready and does a huge amount of configuration of IO paths and things like that. And I'm doing an experiment now where I completely remove all the x86 code and replace it with a core boot that is derived from the QEMU platform. And I am actually getting to the point where I'm loading a kernel. The kernel's not booting correctly, I think, because of APIC and ACP issues. So I know that we've got a few people on here, pretty qualified people. Anybody who wants to get in touch with me afterward and give me a hand with this, it is something we'd like to see happen, and it would be a really allow us to bring AMD, for example, forward in the OSF world. So just want to let people know this is happening, and if they want to talk to me later about what it all means, I'd be happy to talk to you. And I guess with that announcement and 3 minutes left, anyone got anything else to say?
Ron, thank you so much for getting us all together. It's been quite fun.
Yeah, I can't thank this group of people enough. You did a fantastic job. And Brian Cantrill asked me, by the way, is that Rome? Yes, that's Rome. Anyway, everyone, have a good rest of the day. If all the talks continue to be as good as they've been to this point, we're going to have a great day here. Take care.
Thanks all. Have a good one.
Bye.